Okay, let's start with this live stream. This stream we are going to discuss about futures crate. So this is the documentation. Future, we already know it's a Rust trait which has used for asynchronous computation, and it has type and poll, type as output and fn as poll. Very simple trait, but there are some parameters to the poll with pin self and contest, and it will return a poll output. Poll is basically ready and pending. So this is an inbuilt Rust trait, but futures is what we are going to discuss today. It's has some abstractions around those futures, and we can use futures are single eventual values produced by asynchronous computation. Let's see what is this. Yeah, futures and future ext. There you can see um, it's an extension to future trade itself, and this has implemented map into then a lot of good methods. So for example, map, we can give an async future, and future can be mapped, and the value can be received here, and add some value to this, and it will return a new future, and that future can be await here, and we can do assert eq. So that's what future extension. And another one is streams. Stream is a trait built inside this futures crate. It has type item and poll next, and these two are mandatory ones. This is an optional provided method. So the stream of values produced asynchronously, that's the uh, functionality of this trait. If future output equal to t is an asynchronous version of t, yes, then stream item equal to t is an asynchronous version of iterator item equal to t. A stream represents a sequence of value producing events that occur asynchronously to the caller. So basically we can do mapping, iter, those kind of functionalities on futures using this stream. So let's see, we have an example here, a stream ext, that's extension on top of this. So if we have a 1 2 3 array values, and we need to stream it and iterate over it, then we can just do this stream iter and just stream dot next. That will just do same as our normal iterator function, but here it's future, so you need to await on it so that we can get value asynchronously. So that's the purpose of this. And we have map. Where is map? Yeah, here is map. So map, we are iterating same way. We are getting a stream and stream mapped, and we are adding the value, and we can do a collect on this on a vector and do an await, so that it will stream each values, transform it, map it, and transform it, and collect into a vector of I32 in this case, I think. So we don't need to worry on futures. You can do your iterator map, all those functional kind of programming on futures without worrying on um, the internal implementations. So that's the good part of this futures crate and streamext and future.ext. There are a lot of functions, methods built on top of these extensions, trait extensions, so we can make use of them. Let's come back to this example. Here, yes, same way. Let's see, I have a normal Rust main function, nothing fancy with the main function we are printing. But here, block on, there are some fanciness. Block on async main, we are blocking on this async main asynchronous function. We need to wait until this async function get executed. So that's what the block on. We can do some reading, run a future to the completion on the current thread. So this program won't get ended until this async main completes. So let's see what async main is. We are entering the async main and we are getting a number, calling this function. We don't know it's async function or not. Let's see. Yeah, it's an async function and it's waiting ready, futures ready, and just giving a 42, integer 42. If I remove this, will it still compile? I think it's not needed. You don't need to wait for it, but this will automatically convert it to an async function, just returning an integer. Yeah, so let's see what this is. So getting the number asynchronously and map to this transform function, adding a 2, and that's what this future is. It's a map future, implementation future. So we need to do a await on this. That's what we are doing here, so that it will get executed and will receive the value here. Same way vec future, I am streaming 1 to 3. I think 3 is excluded here. Yeah, 3 is excluded here, and I'm mapping that to x plus 2, same way, and collecting this will be a vector, this will be iterator over values. So we need to collect it because there are multiple values coming from this. We can do a future dot collect and collect a vector and dot await, so that it will get executed and we get the vector here. And join is basically, let's see what is join. Join the results of two futures, waiting for them both to complete. So it will wait for dance and learn and sing to complete. So we'll give join on these two async functions. It's just executing a print line, nothing much, and we are awaiting on it so that this will get completed, and we are exiting the asynchronous main so that it will come back here. Then we will exit the main function, normal synchronous function. So that's what we are executing here. So you can also see the flow, entering synchronous main and blocking on async main, coming here, entering async main, executing the number future, transform number, transform vector, executing dance, executing learn and sing, and joining it, waiting for its completion, then exiting asynchronous, coming back here, then printing the final exiting synchronous main. So that's this program. That's all I'm planning to cover in this live. Thank you for watching this stream. Thank you.